Okay, let's just jump right in. For what feels like forever, the role of a process engineer has been, well, pretty reactive. A batch fails, and suddenly an engineer spends weeks, literally weeks, buried in spreadsheets trying to figure out what on earth went wrong. But what if that role could completely flip on its head? What if the engineer could go from being a data detective, always looking at the past, to a predictive, strategic partner working with a whole new kind of AI? That's what we're going to unpack today: the rise of the agentic engineer.
Look, if you're an engineer in pharma or manufacturing, you know this pain deep in your bones. We call it Excel gymnastics. You're downloading these massive CSV files, manually trying to line up timestamps, and just making sense of 1,000 different variables. It's a nightmare. In fact, some studies show engineers spend up to 60% of their time on this. Think about that for a second. That's more than half your week. Basically, your Monday, Tuesday, and Wednesday are just gone, spent wrangling data. This isn't just annoying, it's a huge bottleneck. It's probably the single biggest barrier to innovation, and it keeps our brightest people trapped, looking backwards instead of designing the future. And this slide just lays it out perfectly. These are the two different worlds we're talking about. Over on the left, you've got the current reality for most people: reactive troubleshooting. A batch fails, and bang, it kicks off a 3-week-long, painstaking analysis. That's 3 weeks of lost productivity, with costs piling up, all just to find out why something already went wrong. It's this wall of confusion. But then you look over to the right. Predictive engineering. The whole game changes. Instead of a 3-week investigation, you get a 3-second query. Instead of asking why something failed, you predict if it will succeed in the first place. You go from wrestling with raw data to getting real, physics-informed answers. Now, I know what you're probably thinking. Okay, I get it. Data's a mess, but we have all these amazing new tools. Why can't we just throw AI at it? Why don't just dump all this data into something like ChatGPT and ask for the answer? It seems like the obvious solution in the world we live in now, right? But, and this is a big but, for something as critical as high-stakes manufacturing, that's an incredibly dangerous trap to fall into. And the reason it's so dangerous really comes down to one core concept: AI hallucination. See, a generic large language model was trained on the public internet. It learned from poems, marketing copy, and a bajillion cat videos. What it didn't learn about was thermodynamics, or fluid dynamics, or the unique proprietary setup of your specific equipment. So if you ask it, hey, why did tank 4 fail? It'll give you an answer. It'll sound super confident, but it's just making it up. It's guessing. And in pharmaceutical manufacturing, a guess can cost millions of dollars, completely derail a product launch, and create a regulatory nightmare. So here's the key takeaway. We don't need a generic AI. We need an engineered AI. The real solution is a 2-part system that makes AI both safe and unbelievably powerful for this kind of work. First, you have what's called context engineering. The best way to think about this is like building physical guardrails for the AI. Before it can even think about an answer, we wrap it in the digital nameplate of the equipment. The official specs, the hard physical limits, the laws of thermodynamics it simply cannot break. Second, we use small language models, or SLMs. These are secure, specialized AI engines that run locally right there with you, protecting your intellectual property. They aren't trying to know everything about the internet. They're designed to reason deeply on your specific, high-quality small data, not the messy, chaotic data of the entire web. And when you put those two things together, the physical guardrails and that secure, specialized engine, you unlock something called the agentic workflow. This is where the job completely changes. The engineer isn't spending 3 weeks on analysis anymore. Instead, they ask a simple, direct, powerful question just like this one. In a matter of seconds, the AI grabs the lab data, pulls the physical limits for tank 4, runs a predictive model, and gives back a clear, actionable, physics-backed answer. No, tank 4 will exceed the cell lysis threshold, which basically means the cells would get damaged and the batch would be ruined. Recommend decreasing to 110 RPM. Just like that, the engineer becomes a strategist, and the AI becomes their expert co-pilot. So ultimately, that's the paradigm shift we're talking about. For years, all that data pouring out of your plant has been a heavy liability, something to be managed, cleaned, and picked through after something's already gone wrong. It's just been more work. But by wrapping it in context and pairing it with a secure AI, it's transformed. It becomes an active agent, a partner in prediction. We're moving from a world of slow, manual troubleshooting to one of instantaneous predictive engineering. Which really just leaves us with one final thought. If your data could actually talk, and it understood the laws of physics, what's the very first question you would ask it?